Our project encompassed building and designing and building a 6,000 inch-pound remote manipulator joint for applications in military, Department of Defense. Well, the original application was for an explosives ordnance disposal robot, basically what's being deployed over in Iraq and Afghanistan right now to deal with improvised explosive devices. This was actually an incredible opportunity for us, working in industry, being held to industry standards.
This joint is so unique to industry that it really has applications in, like the commercial industry, I guess in other aspects of the military, like decommissioning of nuclear reactors and things like that. And there's nothing else like our joint right out there. And I think there was a big initiative to find and develop something that could help with a lot of the heavy bomb disposal missions out there in Iraq, which there isn't anything right now out there.
Up in Montana, golden eagle populations are on the decline, and researchers are trying to figure out why they're dying. And so they want to catch them and do blood testing and feather sampling and put GPS on them so they can track their migration routes. But they don't really have a good method for catching them. So they came to us with the idea of creating a robotic marmot that they can put out on the mountain and drive around, and hopefully it looks appetizing enough for mature golden eagles to come down and attack it. They hunt a lot on movement, so we had to get the marmot to look pretty realistic in how it's actually moving. And so, the first phase was designing, what movements we actually wanted to have. So once we had that, we had to figure out, how do we want this, how do we want to make this work? And how are we going to house all of our electronics and stuff like that from an attacking golden eagle? It's definitely a lot more rewarding because with the classroom, you're doing all the work, but you don't get to actually see the finished project. And so with actually having this type of lab and this type of class where we're doing a year-long project, we get to put into use everything that we've learned throughout our college career.
The purpose of the Good Samaritan was for a RoboCup urban search and rescue competition, which is promote research into search and rescue robots. There you're supposed to go through a simulated disaster site such as 9/11, but we're using step fields, stairs, ramps, random debris spaced throughout, and look for victims. Those victims will emit life signs, so they'll have CO2 emission, a heat signature, they might be making noise, they'll have the form of a human, and they might be moving around. We started with a shell of a robot. We had a chassis and then a bunch of electronics that didn't work together. Our job was to take all of those electronics and actually get them to work in tandem with each other and working. Also, there was an interface team, so a graphical user interface needed to be created for the robot. We did that. And then the camera arm had to be integrated to actually work on the robot, and it does that now.
Good Samaritan Micro is it's designed for urban search and rescue, and this is a competition held both nationally and worldwide. And what they do is simulate urban search and rescue disaster, like collapsed building, bridges, and stuff like that. And lately we've been trying to scale the robots down so that they fit into more of the tighter areas of the disaster simulation. Last year they did a half-scale robot, and this year we went down to a quarter-scale robot. A lot of the other robots have a lot of great capabilities, but they're way too big for practical situations. So this one's more along the lines of what would be really required in a real situation.
The experience that I've had at CSU has been very positive, and then the experience also with the Good Samaritan and all of that has taught me a great deal about engineering.
This past 9 months, we've been learning from day one. Just learning, okay, let's build this. Okay, well, how do we do that? Well, our book doesn't tell us to. Let's do some research. So it gave us a good understanding of what we needed to do, and then this project has helped us just grow as professionals. So.
There are a lot of universities out there that don't necessarily have a program like this where you actually make a complete project for a year. And so once you graduate and you're out in the real world, this is something that you're going to be doing. You're going to be given projects, you're going to be given deadlines, you're going to be making schedules and budgets. And so being exposed to it right now, I think, is a great way to gain the experience that you're going to need when you're out in real life.
We were students, but we were working professionals at the same point in time. We had to work. We were treated with the same respect and held to the same level as all of the other people in industry. So it was a great experience being able to transition into the real world.